So today is the Integrating Parts into Assemblies workshop. If you're able to join us yesterday, we were able to discuss how to create parts. So I won't be going over any of that today. That's why I created some project files for you. So I created some pre-done parts, and we are going to learn on how to use those parts in assemblies. So just as a self-introduction, my name's Isha. I'm a part of FTC 18225 High Definition and also the CADTable team. I have been in FTC for around 3 years, and I'm currently one of the co-leads for our CAD sub-team. So CADTable, which is what this is under, is a CADathon where you can participate in either beginner, intermediate, or advanced level CAD competition. So if you're interested in that, make sure to sign up for our competition. But here are some of the upcoming dates if you're interested in attending our Render CAD workshop, which is coming up, I think, next Monday. So today we're going to discuss a lot. So that's why it's 1.5 hours instead of the other ones, which are 1 hour. We're going to talk about what an assembly is. We're going to learn about like the layout of an assembly, how to add parts to assemblies, different types of mates, which is like the main part of assemblies. And then also I do have exercises with those project files for you. So the first thing I want you to do is go ahead and open this link. It's going to be in the chat. And this just has a lot of, assembly files for you, but it also has those project files that we're going to be working with. And hopefully you know how to make these from the workshop yesterday. If you don't, I'm also familiar with this, so you can just let me know, or you could just click on the sketches and kind of see the different components of the part. And once you open this file, you should click on this 3 hamburger menu and click copy workspace. That'll just duplicate the project into your own Onshape account so that you can work with it and edit it. Please don't edit this one directly because that means it ruins the fun for everyone, and that's not cool. And also obviously make sure you're signed into your account because I think that's pretty obvious. Does anyone have any troubles with that? All right. So if you do, let me know. Otherwise, I'll just go ahead and continue. So according to Wikipedia, which I know is not reliable, but this was pretty complex definition, it is a technology and method used by computer-aided design and product visualization computer software systems to handle multiple files that represent components within a product. The components within an assembly represented as solid or surface models. That's really complicated, so I just tried to make a definition of my own, which is basically a special type of CAD file that is specific towards putting parts together. So something like this, which is just a typical metal piece, this is what you'd call a part, and you can put it together to form a robot. Most of you are in the FTC community, so that's why I wanted to use that sort of an example. And this is what you call an assembly because you're putting lots of little parts together. If you'd like to look at the master files, the Zoom bar is being weird. You can see here that we have different parts and we have combined them in a way that they interact. So I kind of I'm probably going to be editing this project file directly. So that's why I also wanted you to copy it because I've already put everything together inside the master files. So once you go ahead and open up your version of the Onshape project, I want you to go ahead and go to the Playing with Assemblies file. And we're just going to kind of talk about what we see here. So at the very top, this is similar to the parts workshop. We have a toolbar at the top. These toolbars are obviously going to be different than the ones on a part because assembly and parts have different purposes. On the left side here, we're going to have the assembly parts and mates. So the parts will go here and the mates will go here. Down here, this is the file name, and this is like the assembly file. And on the very right here, we have a little rotate, workshop, and change appearance panel. And we'll be obviously getting more into these a little bit into the slides. And this middle area is going to be our main workshop. Oh, sorry, workspace. So I'm just going to kind of give you some time to play around with trying to rename the file out of assembly and delete an assembly. Lots of the workshop today is going to be project oriented, but obviously we'll be walking through these exercises to make sure you understand them and also to make sure you get the concepts. So I'll give you around like 5 minutes or maybe 2 to 3 minutes, and I'll let me know if you have trouble with them, and we're going to walk through it after like 3 minutes, I would say. Let me know if I'm going too slow if you have any questions. All right, so I think it's been 2 minutes. This is a pretty simple exercise, or at least if you know how to do it. So I'll just go ahead and walk through it. So the first thing we want to do that says is rename playing with assemblies to assemblies practice. So if you right click on the name of the file and click rename, then you can go ahead and rename it to assembly practice. For those who just came in, we are working with a project file. That is the link. And just click on this hamburger menu and copy workshop in order to duplicate it into your own account. The next thing, activity that we asked is adding an assembly and calling it new assembly. So I'm just going to click on the plus sign and you're going to click on new assembly. Something Onshape is really, really good at is being consistent with symbols. So every single time you see like these two rectangles that symbolizes a part, that's what you dealt with if you were working there in the workshop yesterday. But this like weird 3D box with a little shaded box, that is always going to be an assembly. So we can click on that. We can go ahead and rename it. And it said we wanted to name it to new assembly. And then something that you want to obviously be aware of is how to delete it. So you can go ahead and just delete it. There's also some more panels here. So there is opening in a new browser tab, duplicating it. I use the duplicate a lot, so that might be something you might want to get familiar with. There is copying it to clipboard. I've never really used that before because you can obviously just copy this user link. And I think that is the main parts of it. Another option that you can do now that you've kind of understood how an assembly works is going over to the insert button and inserting parts into your assembly. So I already have lots of parts in here if you are working with the project file. So just go ahead and insert the 100mm circle. And in order to do that, all you need to do is click on it. And you can do the same thing with the 50mm circle. And then in order to place it, you can drag it around with your mouse. And once you find a good spot, just let go. You can also import other assemblies, but since we haven't built anything, there's really nothing to import if we do that. So I'm just going to go ahead and leave that alone for now. You can import stuff in other documents. For example, if I go over and insert something from the CADTable master files, you'll typically have to create a version of it. So if I do that, I can go ahead and let's say insert an assembly that already works. Give me a sec. So I've already built this mini assembly inside the master files. So you can see that I was able to insert that into my project. And then there's also some standard content, but if you are working in FTC, you most likely won't use this because you can just go over to, let's say, gobuilda.com. If you use that, go into one of the pieces and just download one of the step files and use that instead. So most of the time you won't use the standard content tab. So those are the options inside the insert panel. And make sure to insert these two circles and also the cylindrical rod. And you can zoom out using your mouse. You can use two fingers to zoom in or out. And this is extremely similar to the parts panel that we learned about yesterday. I'm just going to go ahead and delete this assembly because it's weird and in my way. And all you need to do in order to do that is right click and click your delete key, or you can right click and unravel all of these options and just click delete. So when you come to this, there are lots of things that you need to kind of talk about. So the first thing we need to talk about is learning how to use this left sidebar over here. So if you right click on something, you notice that we got lots of options. So lots of the time you're going to be using fix, which would just fix it in place. You're going to get this little icon. And what that means is that you can move things around it, but you can't move the piece itself. It's fixed in place. That's really helpful if you're working with animations. So you can fix one of the parts in place and then you can have the other one move, just because it's easier than having both of them move. Something else that we are going to be working with is hiding pieces. So you can right click and hide it, and that just removes it from the workspace. It's still a part, but it's hidden. You can't see it. Another way to do this is just clicking this eyeball. All right. The next part I want to talk about is probably something that lots of people like to do. I was having lots of fun playing with this, is that if you click on this little cube right underneath this rotational cube, so this rotational cube rotates the canvas, and you can click on different aspects of it to focus on different parts of this front top right cube. If you click on this, you can click on different options and it changes how these pieces look. one of my favorite ones. That's not one of my favorite ones. Oh, that one's a pretty cool one. Let me see whether I can find it. I can't seem to find it, but it's all right. At least you understand that this can change how it appears. You can also create different files. Let me close this panel here. You can also create a folder. So for example, if I create a folder called parts, I can move these different pieces into these parts folder, and that just makes it a lot easier for navigation and also organization. And the last thing, I already talked about this, but you can go ahead and fix different parts by right-clicking and clicking fix. You don't have to directly click them on this navigation bar. You can also just click them right over here. All right. So I'm just going to give you some time in order to build this part over here. And I know that you didn't learn how to make pieces together yet, so just use the fixing in order to secure them in place. And I'll probably give you 5 minutes. And this design is pretty interesting, but you use one of these in order to do so. So I'll give you some time in order to try and build this. And let me know if you have any questions, because it just takes in everything that we've learned so far. And it uses these 3 pieces, so you shouldn't have to import anything else. I'll go ahead and paste a link of the master files inside the chat so that if you're interested in looking at it, you can do so. So those are the master files. Oh, there we go. Curvature of visualization. That's the fun one. You can do all sorts of stuff with it. It's also really fun to rotate. I'm not sure whether you learned this in the previous workshop, but it's always really helpful to have a mouse when you're working with CAD. But you don't need to. I did lots of my CAD without a mouse. All right, if you're looking at my screen, this is probably making you dizzy, so I'll just go back here. Also, it'd be really helpful if you raise your hand to put an emoji once you're able to complete it, or if you have any questions, you can type in chat or let me know. All right, great. So I saw one thumbs up, so I'll just wait maybe 2 more minutes for you to complete the exercise. And then I can quickly walk through how to do it. Okay, cool. So I think it's been 5 minutes since we started this exercise. So I'll go ahead and quickly walk through it. So once you have your three parts in place, which are the three that we just kind of imported at the beginning, just go ahead and place one of them, fix it, place the other one. And if you're just fixing things, it's really hard to do so. So you can kind of just rotate the view in order to make it easier for you. So that kind of looks like it's towards the center. So I'm going to go ahead and fix the blue piece as well, just by right clicking and fix. And then you can put the last piece through it. And again, rotating your view makes it a bit easier in order to do so. And you can right click and fix. That does look a bit wonky, but it's probably one of the best that we can do if we don't mate things together. And then if you want to make it like this weird curvature projection, you can just click curvature visualization in the small appearance cube, and you can edit these different options in order to get how you want to look like. And when you rotate, it does look pretty cool. So that is a basic introduction to assemblies. We were able to learn how to import parts, how to create assembly files, change their appearance, and we did quite a lot. But I kept bringing up this concept of using mates. And I'm just going to go ahead and talk about that. So mates aren't like friend. That's not really what I was talking about. I was talking about how you could combine pieces together more definitely so that you don't have to just fix them and kind of guess check your work. You can precisely fix them and also possibly get animations like you can see in this GIF. And hopefully by the end of this, you can do the exact same type of animation. So a mate, if you take a look at the panel at the top, there are a few different types of mates, and you can view them at the very left of the toolbar right beside the import parts. And I'm just going to go ahead and use this Revolute mate in order to bring up a few points related to the component of a mate. So the first part is that you need two things in order to mate. So I'm just going to unfix two of, okay, this view is messing with you. I'm just going to change the appearance back. And I'm just going to unfix two of the pieces. And I'm just going to hide this millimeter circle. If you click on the Revolute, The first thing you need to do is you need to add two things in order to mate. You can mate two surfaces, you can mate two points, you can mate two edges. And if you hover over a specific piece, this little yellow like a circle thing is what determines where it's going to mate. So here it's going to mate the entire surface because you can see that pretty much the entire surface is highlighted. If I'm clicking on this specific edge, you can kind of see how it folds around the edge. So that means that I am mating that specific edge. I want to, for example, revolute this surface. So I can click on the surface and you can see that it adds it to mate connectors. And then I can click on another surface of another piece in order to mate them together. Once you have your mate, you can change it because all mates require at least mating two things together, even if the different types of mates are different. And we'll talk about what the difference between all of these are. Just go back to Revolute for now. You can use this arrow to flip the direction of your mate. Do you want them to be parallel or do you want them to be on top of each other? You can also rotate the piece, but you can't really see that because these are cylindrical. Two important things that I want to talk about are these offset. So you can move where the piece is. If you can't find a perfect mate, for example, you can't mate in the middle of this cylinder, but you want to mate that to this edge, then you can use an offset in order to roughly get that approximation. You can also rotate a piece along the mate, and you can rotate it along different axes. So you can rotate it along the X, you can rotate around the Y, and depending on the different type of mate, you would be able to rotate around different axes or have different offset capabilities. So X, Y, and Z rotate it either like direction, so up, down, or the third space. I don't really know what that's called. Or you can rotate it around the X, Y, or Z axis. Another thing that is pretty important to talk about are limits. So this is more important when it comes to animations. So we're going to go ahead and just talk about it when we get to that step, just because it's a lot easier and it makes a lot more sense. And then once you go ahead and have a mate, so for example, I'm just going to fasten these two tops. And we'll talk about these different types of mates. So if you're getting a little bit lost, then I'll talk about them more in depth in a sec. You can right click on a different fasten and you can edit it. That's what I use a lot when I don't get it right the first time. You can rename it and do a whole bunch of stuff. So I was talking about lots of different types of mates in that a tutorial kind of a thing. So these are the 9 different types of mates that you have available in Onshape. You have a fasten mate, you have a revolute mate, you have a slider mate, planar mate, tangent mate, cylindrical mate, pin slot mate, ball mate, and parallel mate. None of these really matter if you don't want animation. The only thing that would really matter is fasten. But if you want to kind of simulate how your thing would look like in real life, this is extremely helpful if you're in, for example, robotics, where you can simulate pieces in when you're custom printing 3D parts. You can see how it works with the rest of the robot and therefore print more precisely before you just print repeatedly until you get things right. Let's go ahead and talk about what's different between these different types of mates. So the first thing is a fasten mate. A fasten is super similar to a fix, meaning that once you mate them together, you can't move them. They'll always be stuck together. So you can move them together, but you can't move them individually. So according to Onshape, that means mate 2 entities and remove all degrees of freedom between them. So if you go ahead and go into your fasten assembly, you can go ahead and insert your a door and the doorknob. So when you have a doorknob on your door, you don't want the doorknob to just like pop out. That's kind of weird. So what we're going to do is that we're going to fasten it to the door so that it doesn't move. Or to do that, click on this little icon here. This is always going to be a fasten me icon. You can also rename it over here. So I'll call it the doorknob joint, or you can call it the doorknob mate. Whoops, I did not spell that right. I'll just retype it. You want to define your mate connectors. So the first thing would be the doorknob, and the second thing would be this door circle. And then you can click solve if you want to see how it looked like inside the entire project. It looks pretty good, so I'm just going to go ahead and click enter. And you're going to go ahead and see that we have our doorknob and our door. And if I drag it around, I can only drag the door around with the doorknob. I can't move them separately. So that's what a fasten means. And if you go ahead and fix one of these in place, oh, that's not what I want to do. If I want to fix one of them in place, you can see that I can't move any of them because they have to move together. That's what fastens does. The next, it'd be also really helpful for you if you follow along with me inside your project files. So let me know if I'm going too fast. You can also like chat it to me if you're not comfortable on a meeting. But it just helps me keep pace with the class so that I don't end too early or you don't get anything by the end of this. The next thing that you kind of want to keep in mind is the revolute mate. And this mates two entities allowing rotational movement about the z-axis. Essentially, in two directions, it mates it, and in one direction, you can rotate it. So as you can see in this clock, I can rotate it in this direction, but it can't move it up or down. So it fixes it in one position, but allows you to rotate. So that's why it's called a revolute mate. And if you go ahead and go over to the revolute panel, you can go ahead and insert a clock arrow and a clock frame. You can use your mouse pad or your physical mouse in order to zoom in and out. And once you've got the pieces inserted, just go ahead and click enter. Okay, perfect. So if you wanted to fasten this, you don't have to do this on your project files. I just want to show you the difference. So you notice when I fasten this, I can't move it around. Okay, I'm just going to go ahead and fix this clock frame so that I can prove my point more easily. I can't move this clock arrow. It stays in place no matter how hard I try. But if I delete this fasten and I go ahead and use this revolute mate, I click the outside of this arrow, or you can click the inside. Both of them work. I'm just going to go ahead and click the inside because that's what goes around the little stick on the clock. And I click this little circle here. And I use this arrow to make it pop up, and I press OK, meaning that I like my joint. You can notice now that I can rotate it, but I can't move it up or down. I can only rotate it along this axis. If all of this terminology is hard for you to remember, then I try to pick out these examples to be different from one another. So you can also remember the example to the name, and then that kind of just helps jog your memory on what the joint is. For me personally, I typically use the fasten mate the most and the cylindrical mate, which we're going to talk about next. Oh, not next. We'll talk about that later. The next thing we're going to talk about is slider mates. You can kind of tell from the icon or this GIF here that it means that you can make things slide. So I'm just going to go ahead and go over to my slider assembly tab. I'm going to insert the circular rod, This Zoom bar is being very annoying. Sorry. And can't see it. If you can't see one of the parts that you want, you can also go ahead and search it up. So it looks like it's called square container inside project. So I'll just search it up. You can see that now it pops up. So I'll just go ahead and insert it. Oh, sorry, restore. And you notice that the origin's hidden, so you can go ahead and unhide that. I'm going to move this square box to the center, and I'm going to fix it in place so I can't move it around. So the slider mates two entities along the translational movement along the z-axis. So very complicated terminology for saying in the revolute mate, you can rotate it along one axis while two of them stayed in place. Now you can move it up and down in one of the axes while the other two stays in place. So you can see here, I can't move it left or right or up and down. It stays inside this square hole, but I can move it up and down. So in order to do that, you just go ahead and click on the slider mate. It looks like a slider mate. It looks pretty much like what it is. You can click the outside rim of part 1, zoom into the second part and click on the rim for that. This looks pretty good to me. So you can also just flip it if you want to prefer it to be that way. It doesn't really matter, but depends on your preference. And click OK when you think it looks good. And now you can see that you can slide it up and down, but you can't slide it left to right. But here's a problem. It goes way too much past the part. If you look at the GIF, it kind of stops right when it needs to stop. So in order to do that, what we're going to do is we're going to go ahead and edit this mate, and we're going to address the limits now. Limits basically sets how far the part works, I guess. So it basically says you can't go below this point, you can't go above this point. So if you look right now, there's no minimum or no maximum. I'm going to go ahead and set the maximum to 0.0 because this is as far as I want it to stick out. If you press OK, you can see that I can't go back down, but I can go as much up as I want. That's not what I wanted. So if you edit it, you can make the minimum 0 and then just delete it in order to make it have no maximum. And now you can't go more up, but you can go as down as you want. In order to fix the down issue, you just edit the joint. And we're going to add a maximum. I'm not quite sure how tall it is. I'm just going to guess 300 milliliters. You can also click this play icon in order to animate it. You can see it went way too far. So I'm just going to go ahead and try 150. And that looks pretty good to me. So I'm just going to go ahead and click OK. And you're going to notice that we've added a limit to our mate. All right. So that's how we are going to add our limits to our mates. And if you came late, I'm not sure whether you can see the project file, but it should be in the chat. Let me know if you can't see it. And that's where all of this parts are coming from. All right. The next exercise you're going to do is a planar and tangent mate. I personally haven't really used this in robotics before, but I really love this blue circle and purple circle animation. So, oh, whoops, wrong tab. This Zoom bar is really annoying me. Okay, just go ahead and go into the planar and tangent file right over there. And we're going to go ahead and insert our two circles. I'm going to fix one of them in place. I'm going to show you why I've been fixing them. If I don't fix it in place, Okay, maybe this might not be you can see that as I'm trying to animate one of them, one of the pieces moves and that just gets really irritating. So that's why I fixed one of them just so I can see my animation a lot more clearly. So I'm gonna move this purple circle in order in the middle. I'm gonna go ahead and, okay, that is not what I wanted. There we go. Gonna move that back and I'm gonna fix it in place. And I'm gonna go ahead and use the planar and tangent mate. So the planar mate basically makes the planes parallel to each other. So you can't really disturb the plane by going this way, but you can just go along this way. You can rotate it as long as the planes remain parallel. The tangent mate, really similar to tangent in math, it makes it so that these two surfaces are tangent to one another. So tangent is a little bit different than the other ones because it doesn't really affect the axes as much, or axes, depending on how you say it. It mostly affects the faces and edges and vertexes of the actual parts themselves. So I'm going to go ahead and do the tangent mate first, just because it makes more of an effect when you first see it. So I'm going to go ahead. I'm not going to click one of the actual surfaces. I'm going to click this face right over here, this round face. And the second round face is the one of the purple circle. You notice that it is tangent, but isn't going the way we want. You can kind of notice that it's really going anywhere, except for it is kind of tangent to the piece. But since they're circular, you can basically move it anywhere and it'll be tangent in some plane. That's not what we want. I'm also just going to delete this and show you the planar mates, the planar mates separately. So if I mate these two surfaces, so I'll mate the top of this circle and the top of this circle, you notice that, yes, the two surfaces are parallel in no matter what orientation you do. Can't really rotate it because that removes the parallel, but you can move it anywhere, and that also kind of destroys the purpose that we're aiming for. So one of them makes sure that they remain on the same plane. Planar makes sure they're on the same plane. Tangent faces that problem. So if we go ahead and use both tangent and planar together, you notice that the planar makes sure they remain on the same plane, and tangent makes sure they remain tangent. So that's an example of how you can use logic, but also multiple mates in order to solve your issues. So now you can notice that it's animating pretty smoothly. If you wanted to automatically animate, you can go ahead and right click on one of the animations. So I'm just going to go ahead and right click on the planar. You can click animate. And you can kind of edit your settings on how to animate the mate automatically so that you don't have to use your cursor in order to do so. But I'm going to save that for later in the lesson. That's just a little sneak peek. The next mate, I hope I'm not boring you with all of this. My idea was that y'all just try the exercise and I walk through it afterwards, but I'm not sure how much you're getting out of it. So I'm just going to walk through all the examples and let me know if you need help or want me to slow down. All right. So the next mate is a cylindrical mate. So if you go ahead and go over to, let me switch tabs. And I'm just going to import the circular rod and the bigger arrow. Perfect. And the cylindrical mate, I use this quite a lot, allows you to both rotate and translate over the axis. So you can see that I can rotate, but I can also move up and down. That makes the animation look kind of weird because you're animating two things, but it is pretty good. So what we can do, you'll notice that it is basically the same process. You just click the thing that you want to, the two things that you want to mate together. And it's just like how you want to animate it to determine how it's going to look like. Oh, whoops, I forgot to fasten. Oh, I forgot to fasten the rod. Give me a sec. Okay, there we go. I'll just go ahead and fix it. And then you can notice that you can both move it up and down and rotate it. And you can also, if you right click and edit, you can also add some limits. And this time, you not only have limits up and down, but you also have limits on rotation. So if I if I set the minimum and maximum to be 0 to 90 degrees, you notice that it can't go beyond that. I can't rotate like all the way around. I can only rotate to 90 or 0. All right. And that is the cylindrical meat. We have 2 more to go. And then I'll give you some time to just play around with them because I've been lecturing a lot and that's probably really boring for you. All right, pin slot mate. Pin slot mate is when you have a slot and you have something going through. Pin slot mate. Makes a lot of sense. I personally haven't used this a lot, but we are developing a piece that is kind of like this. So that's when a pin slot mate would be helpful in order to animate it to tell you how it would look like. So this one, a bit different than the cylindrical mate. Instead of being able to rotate and move up and down on the same axis, you can move side to side on one axis and then move up. You can rotate on another one. All right, so if I go into the pin slot, I'm just going to go ahead and insert my slot and insert my pin. I wish I could make these more themed, but I'm not really that creative. So that's why these are just kind of bland parts. I'm going to pin slot it. I'm going to pin slot this. Here's the thing. If I pin slot this side and I pin slot this side, oh, whoops, that did not register. Yes, that will work. But I also want to show you how you don't have to mate it like that. You can also mate, specific edges. So for example, if I want to pin slot, I can pin slot this specific edge, and I can pin slot it to this edge right over here. So you can also not only pin slot from face to face, or actually this works for all the mates. You don't only have to do it on faces, you can also do it on edges. And then if I go ahead and fix this slot in place, you notice that I can rotate and also move up and down. And this is something where if you wanted to also add a planar mate, planar mates are pretty good, like complementary to other mates. Oh, oops. If you add both of them together, you notice that they contradict each other. So that is what this red exclamation mark means, which means you're going to have to delete one of them. I'll just delete this planar one and we can deal with this pin slot one for now because that was the purpose of this exercise. Alrighty. And the last one is a ball mate. You can't really tell from here because it is supposed to be a ball, but this ball is rotating. So if I go over to the ball assembly and I insert okay, I don't think is it the doorknob? I think it's the doorknob. And the socket, I could go ahead and rotate this upside down. And I'm just going to go ahead and ball mate this interior part to this ball. And let me fix the socket real quick. you notice that fixing it is really helpful. You can kind of see it, I guess. It'll be more evident if you like add something to the ball and rotate it that way, but I couldn't really do that like properly. So we're just probably gonna leave it here. I mean, if you'd like to, you can add another ball. You can fasten it to this one. But you notice that it doesn't really work well. Oh, I know why. There you go. You can use the offset tool that we talked about in order to move the ball away from one another. Oh, maybe not that much. 2. There we go. And now you can use this in order to kind of tell how the ball is moving with the ball joint. All right. So those are not all of our mates. We have one more. I'm just going to talk about this one. I've never used this before, so I don't really know where it'd be applied because the other ones pretty much cover a lot of stuff. So this just allows parallel rotation on one of the axes and translational movement along another axis. We do have 30 minutes left. I don't anticipate I'm going to take all of that time. So you will have lots of time in order to ask me questions if you'd like. Groups are, again, not groups of friends. We are talking about groups in CAD, obviously. So groups are basically locking the position of selected entities relative to one another. Complex definition, but basically it's saying that you can have two objects, they just exist, they're not connected to one another. For example, I can have these two erasers, they just exist in space, and I want to move them together, but I don't actually want to mate them. That's when you'd use a group. A group can be helpful in a lot of places. So I'm just going to go ahead and show you where a group is. So group is just right over here. I'm going to remove this fasten, and I'm just going to go ahead and group this object with this object. And you notice now that they stay in relation to one another, but they don't actually have to be touching in order to do that. So I remember earlier that we faced a problem with putting these two balls together. We solved that using a fasten mate, but you can also use a group mate by just putting them close together and then grouping that in that position. So that works as well. And groups are particularly helpful when you can't find a good mate in order to make them together in the way that you want. But mates are obviously always much better than groups because they have more flexibility, allow for animations more easily. And also, if something in your project changes, at least they stay together. Groups, they're kind of like imprecise. Fasten, you gotta like define exactly where that joint is. But group is like, oh, I want it roughly here. I want them to be roughly this close. But mates can be definitely a lot more precise than that. So that's why in this example, group might be better than a mate, because if you want it to be at the absolute tip, in a fasten, you might have to determine the exact value on how far away you want it to be from one ball to the another. On a group, you can say, well, roughly, I want it to be like that. So let me just group it. And that just solves a lot of your time. So you can either do that in the group tab, or I just went ahead and did the ball tab. So you can delete the group tab if it's not helpful for you anymore. Perfect. All right, so this is probably the most fun part of the lesson today, and it is just animating. So I'm going to go ahead and go over to the Revolute tab. This is a pretty nice thing to animate because it is pretty straightforward, and we like stuff that is straightforward. So instead of us having to physically move it, we can actually have Onshape physically move it for us. So that is what animations are for. Animations just animate things directly. The first thing you could do is right click on this mate, click the start button, but you can notice that it isn't really continuous. It just goes one and then it stops. If you want it to be continuous, you can right click on this and you can click animate. And you can just click the play button and it'll go ahead and animate. You can make it loop. Replicate means that after it's done, it's going to go back to where it started. But if you don't want it to do that, you can just loop it. This is pretty slow in my opinion, so just decrease the number of steps you have and it goes a lot more faster. You can also reverse the direction it goes. This is where you only want it to go once and it stops. And you can just edit all of those values. So that's really it on my half. You can probably go ahead and animate other things as well. So if you animate a slider mate or a mate with limits, you can see that the animation obeys to those limits. I just wanted to make it a bit faster. And you can see that it goes ahead and animates it for you. Oh, this would actually be a great animation for if you wanted to animate like a needle pressing. That's actually pretty cool. Anyways, feel free to just use all of this in order to do something cool and hopefully build. This was extremely helpful for your CADTable competition or your robot. Don't forget to go ahead and sign up for the CADTable competition if you're not already. You can learn more about the competition on our website, and you can sign up on our dev post, which is also linked on our website. So thanks for attending. If you have any questions for me, let me know. I'll probably stay back a bit, but I'll post our team's email in chat. So if you have any questions, you can always reach out to the team email. So with that, if you have any questions, let me know. But otherwise, I think that that's it for today. Thanks a lot for coming.
I actually did have a question, but it's mostly more on the presentation of your CAD. So what rendering software do you use?
So the first thing that we did is that we got all the parts to have the same color in CAD. And then we go ahead and use Fusion in order to make it a lot more pretty. There's a workshop on that next week, Monday, and the person who did rendering will be teaching that. So I think that you can ask more specific questions there.
Oh, okay. Thank you so much.
Yeah, of course.